pressure exerted by a solid and pressure exerted by liquids. What is the difference? Imagine a wooden block placed on a horizontal surface. Now, due to the weight of the wooden block, due to the downward force, the gravitational force on the wooden block, it will exert pressure on the surface below it. Can you see a wooden block, a solid block, will exert pressure only on the surface below it due to its weight? Whereas in the second figure, imagine a liquid placed within this vessel. A liquid will exert pressure not only on the bottom surface, but also on the side walls. So a liquid or even a gas, which is completely enclosed within a particular region, will exert pressure not only on the surface which is below, but also on the side surfaces. Okay, so on all surfaces of the container, these fluids will exert pressure. Now, pressure exerted by a liquid increases with depth. What does that mean? Imagine a cylinder having water up to a certain depth. Now, if there are 3 holes in that cylinder, one at the top over here, one somewhere in the middle, and one at the bottom, the water will flow out through these holes. But through which hole will the flow be the fastest? Water will come out with greatest force from the bottom hole. The reason is the pressure at the bottom of this tank would be greater. Pressure increases with depth. Hence, if you ever go to a swimming pool, you would notice that if you go deeper into the water, the pressure increases. Whereas when you come up, the pressure is lesser. So, point to be remembered, pressure in a liquid increases with depth. How much is the pressure? How do you calculate the pressure inside a liquid? Pressure due to a liquid is given by the formula P is equal to H rho G. This middle term is called as rho. Okay, it is a symbol for density of the liquid. Rho stands for density. So let's understand all the 3 terms. H is the depth of the point below the surface. So for example, if you are calculating the pressure at the bottom of this vessel, which contains water, suppose. So the pressure at this point, for that, H will be this depth, the depth of the water. Okay, you can call it the height if you want. H stands for height, or you can also call it the depth. Below the surface, the depth is to be taken as H. Rho, as I already told you, is the density of the liquid. And G, small g, is acceleration due to gravity. We take the value of acceleration due to gravity as 9.8 meters per second square. Or sometimes we approximately take it as 10 also. So pressure due to a liquid at the point inside a liquid would be given by H rho G. This is the formula you need to remember. Now, this is the formula which gives you pressure due to the liquid. But outside here, there is atmospheric pressure, pressure due to the air, due to the atmosphere. So the pressure inside the fluid here will actually be the addition of 2 terms. One is the atmospheric pressure, the total pressure will be given by atmospheric pressure plus the pressure due to the liquid, H rho G. Okay, so the pressure inside a liquid is due to 2 things. One is it is due to the liquid, that is H rho G. Also, the atmospheric pressure gets added to it. So the total pressure is the addition of 2 terms. For solving numerical problems, pressure is H rho G. We already saw this formula. That is due to the fluid, the pressure due to the fluid. Whereas the total pressure at a point inside a liquid will be atmospheric pressure plus H rho G. Now, how much is the atmospheric pressure at normal sea level? Remember, atmospheric pressure decreases as you gain altitude. As you go to a hill station, atmospheric pressure would be lesser. But normally at sea level, the atmospheric pressure is taken as 1.013 into 10 raised to 5 pascals. I would advise students to remember this value. This pressure 1.013 into 10 raised to 5 pascals is also called as 1 atmosphere. The value of G to be taken as 9.8 meters per second square. Sometimes in the exam, they might ask you to take the value as 10. Let's go through the thrust on the base of a cylindrical vessel. Suppose there's a vessel containing water. How much would be the thrust, the force acting on the base of the vessel? So that will be given by pressure multiplied by the area of the base. We know pressure is thrust upon area. So the thrust would be pressure multiplied by area when you cross multiply. Okay, so pressure at the bottom of the vessel multiplied by the area of the base would be the thrust acting on the base. Let's look at the units for pressure calculation. This column gives you the SI units and the next column gives you the CGS units. Pressure we saw is measured in Newton per meter square or Pascal. In CGS units, it is dyne per centimeter square. Height of liquid column, H, the H that you use, the depth or the height of the liquid column is in meters or in centimeters. In SI unit, it will be meters, CGS unit, centimeters. And density rho will be measured in kg per meter cube or gram per centimeter cube in CGS units. Remember all these units. There is a law called as Pascal's law. Let us see what this Pascal's law states. Pressure exerted anywhere in a confined liquid. Confined means enclosed. Imagine a liquid is enclosed completely. And on this enclosed liquid, suppose you exert pressure at any point. Then this exerted pressure is transmitted equally and undiminished in all directions throughout the liquid. Let's understand this once again. Imagine an enclosed liquid and suppose you exert pressure at some point, at one particular point in the liquid. That pressure will get transmitted everywhere, all throughout the liquid. The pressure would increase. It won't increase only at that point where you exert the force. The pressure will increase all throughout the liquid, equally and undiminished at all points throughout the liquid. Hydraulic machines. Hydraulic machines are machines which work on fluid pressure. Hydraulic machines work on the basis of Pascal's law. And what are these hydraulic machines? You have got hydraulic press, hydraulic brake, hydraulic jack. Your automobiles have hydraulic brakes. Hydraulic jack is a machine used to lift up very heavy loads. So all these work on the basis of Pascal's law. Let's take an example to understand Pascal's law better. Imagine a cylinder over here, a cylinder whose circular area is A1 and another cylinder here. So these are two cylinders on two sides, but they are connected at the bottom. This cylinder has a circular area of A2. It's a larger cylinder. Now, the pressure on the liquid over here in the smaller cylinder, the pressure would be given by force upon area, F1 upon A1. F1 is the force exerted by this piston. And on the other side, the force is F2. F2 is the force exerted by the weight of this car. It could be a larger force. Now, what is the principle behind this? It is Pascal's law. And for solving numerical examples based on this system, we will always assume P1 is equal to P2. That is, the pressure at this point and the pressure at this point. Since they are at the same level, in the same fluid, the pressure P1 and P2 would be equal. But P1 is F1 upon A1 and P2 is F2 upon A2. Okay, so if you just cross multiply, rearrange terms, you get F2 upon F1 is equal to A2 upon A1. In other words, if A2 is very large compared to A1, the area of this larger cylinder is very large compared to the smaller cylinder. Then a larger weight F2 can be lifted by applying a smaller force F1. A smaller force applied on this smaller cylinder can lift up a larger load on the larger cylinder. Okay, so F2 upon F1 is equal to A2 upon A1. In numerical problems, out of these four quantities, F1, F2, A1 and A2, out of these four quantities, three would be given to you. The fourth would have to be calculated. But remember one important point, in doing this calculation, the units of F1 and F2 need to be the same. Both could be in Newton, both could be in kgf, both could be in gram force, anything is okay, but both should be in the same unit. Similarly, A1 and A2 also should be in the same unit. It could be meter square, could be centimeter square, could be millimeter square. The units should be same for both A1 as well as A2. So keeping the unit same, you can then calculate these ratios and get your answer.